If you're going to be using any of the things you learned about in this course in your future careers, it will probably be what you learn in Chapter 7, or at least an extension of what you will learn in Chapter 7, linear regression. We'll set up the stage with a scenario that will motivate what we're going to do in linear regression for the rest of the chapter. Then we'll talk about the coefficient of correlation, the linear coefficient of correlation. We'll talk about simple linear regression proper, and then we'll talk about hypothesis testing for linear regression, confidence intervals and prediction intervals, not quite the same thing, that's a new concept for linear regression, the analysis of variance, also known as ANOVA, and then eventually the coefficient of determination, which we can use to determine how well the linear regression model fits. Now, for all of these, we're just going to be presenting an introduction. Like you could spend a full course doing nothing but regression analysis. This is the scenario that we will consider. We have a number of paired measurements, 20 of them. 2 variables, an X measurement, which is the hydrocarbon level in some fuel, and a Y measurement, which is the pure oxygen level in some fuel. So we've taken 20 samples of a fuel, and we've measured both the hydrocarbon level, the X values, and the pure oxygen level, the Y value. So here we have your 20 observations. With this data set, what we're going to try to do is to measure the strength of association between X and Y, and the basis of the strength, to try to describe the relationship between X and Y, between the variable X and Y. At first glance, it isn't clear what the relationship would be. All the values X are small numbers, and all the values for Y are large numbers, and there doesn't seem to be much of a pattern, at least not when you look at the data here as a table. The value of X jumps by adding 0.03, and the corresponding value of Y reduces by 0.96. So if this is the pattern, we might expect that if we have a bigger jump here, jump of 0.13, we should see a further decrease. It's not a decrease at all. What we're seeing is an increase in the value Y. So what is going on? If you take the time to prepare a graphical display of the joint values of X and Y, it certainly seems as though there's a relationship. On average, when X increases and the hydrocarbon levels increase, it looks as though the corresponding oxygen levels also increase. So roughly speaking, this is the kind of relationship we think we're seeing. But there's a fair amount of noise, there's a fair amount of randomness. It does seem though as though the points are all aggregating or lying around a hidden line, a hidden curve. This hidden line, and how to find it is going to occupy our time for the next few seconds.